Okay, let's go and graph this equation. Y equals 1/6 x plus 3. And to graph this, I'm going to use a table. So we got our x's and y's. This is going to give us a set of ordered pairs. In fact, many sets of ordered pairs. And the first value I'd like to try is with x is 0, because 0 is a very easy number to work with. So I would rewrite the equation, y equals 1/6 x plus 3, and then I would replace the x with the value I've chosen, which is 0. Now this will give me a corresponding y value, which when I put into the calculator, I get 3. So I end up with this ordered pair, 0, 3, which I will now put on the graph. And I'll get several points on here, well, a few at least. And here's one of them. Okay, that's my ordered pair at an x value that's 0 and a y value that's 3. Next, we will make an x value that is 6. Now, the reason why I'm skipping 1, 2, 3, 4, and 5 is because 6, when I multiply it by 1/6, is going to give me a whole value. So let's go and rewrite that equation. And now that I have it, I've already chosen a value of x. Let's go and replace it with 6. And again, I'm going to put this into the calculator to find its corresponding y value. So again, it's like a function. If I put in 6, which I've just done, what is going to come out? Well, when I put it in there, it's going to be a value of 4. So this is an ordered pair of 6, 4, which is good to put on there because I can fit on 6. X value is 6, y value is 4. That's right here. So that would be the ordered pair 6, 4. Now that'd be fine if we were putting this on a computer, but I can fit one more point on here. And so I'm going to choose an x value that instead of 6, I'm going to choose -6. And what this is going to do is it's going to do the same thing as +6, but it's just going to make that negative multiplied by the 1/6. Okay, so I have y equals 1/6 x plus 3. Again, now I've chosen an x value that is 6. So again, I am putting in 6, and then I'm looking for what comes out. So I put this in the calculator. I see that comes out. Oh, that should have been a -6, by the way, but that would have been +2. So this gives me the ordered pair, -6, 2, which would be right here. So I'll label that point at -6, 2, and that's all the points I can fit. If you were to use 12 as your x, and again, I'd use 12 because it's a multiple of 6, which is the denominator, then you'd have 5, but 12 is way over here, and then it's off the graph up here. So now that I have all the points on the graph that I can fit, I'm now ready to draw the line between the values. So let's see if I can do this decently. There we go. And I'll put arrows at the end indicating that this line goes on forever, both for our domain and range. But that is the graph of the equation using a table. Again, this is what we were doing last time. So just as a quick review as well, we're using this method now because it seems to work better for us. In, I think it was Unit 2, we were using the y-intercept and then the slope to graph the points, which if you understood, you can still do. But since about 98% of the students this year were struggling so bad with that, and it seemed like the function stuff was actually clicking, I'm going to stick with this stuff. And we're going to see more of this stuff today because we're no longer graphing equations, but we're going to be looking at inequalities instead. So there's our two objectives for the day. I can graph linear inequalities with function input and output, which is just using a table. You choose what's going in, and then we figure out what's coming out. I know where to shade on the graph. That's going to be important for us because we've never actually had to shade a graph. When we were looking at linear inequalities with just one variable, we're just looking at which direction the line goes. Now we have to look at a two-dimensional graph and then shade an area of that graph. We'll talk more about that. So this is what I'm talking about. We already looked at this kind of stuff. What was that? Section 1 and 2 of this unit. And we say up here, we've already seen this exact question. Find a value for x that would make the inequality true. So for this, if I were to say, let's say x, it says, and this is reading that x is less than or equal to 17. So I need to find some values that are either less than or equal to 17. So the biggest one I can think of is 17. That would make it work. I could make it anything less than 17 as well. So if I wanted to say, you know what, I'll make it 16 or 15. See, I'm just going down. And I'm not using any decimals on purpose, but this would go down to infinity, to negative infinity, rather. And so there are, down here it says how many values can make the statement true. There are infinite values that make this statement true. Okay, and that's where we're going to see this again with inequalities now that have two variables, because now instead of seeing it as something like x is less than or equal to 17, we're going to see something like maybe y is less than or equal to x plus 17, something like this. Now we're looking at two values, so we have to put this on a two-dimensional graph with an x-axis and a y-axis, and then we have to check either side of the line. We'll talk about that. So when graphing linear inequalities, we're going to graph the inequality just exactly like it were any regular equation. So again, we're going to use inputs and outputs, but whatever the inequality is shown, I'm actually going to ignore it and then treat it like an equation, because the equation is where the line is. So the line is important because it tells us where the line goes, and the line tells us where we're looking at changing from either true to false or false to true. I didn't put that in there, but vice versa on this, okay? So the inputs and outputs that we're going to be using in this first step tell us where the line goes on the graph. Then, after we get that on the graph, then we look at either less than, greater than, less than or equal to, or greater than or equal to figure out what kind of line to use. Because if it's just less than or greater than, then the line tells us values that immediately start to make the inequality false, meaning that the values on the line are false, and so we use a dotted line or dashed line to communicate that. If it has the equal to sign, then we treat it like an equal equation, which means we're going to be using a solid line, which we do for equations, okay? So if we don't see that equal part of our less than or equal to or greater than or equal to symbols, then we have to, if we do not see it, then we have to use the dotted line. Okay, so at this point, after this second step, now we see on the graph a line, and maybe it's dotted, maybe it's solid, but we know at least at this point what kind of line it is. Step 3 says, is going to help us, well, steps 3 and 4 will help us to know which side of the line to shade on. Because once you get a line on the graph, so I'll demonstrate that here, okay? So let's say this is my axis. I'll be on my x-axis and y-axis. By this time, I would have had a line on the graph, so this would show something less than or equal to or greater than or equal to. Then we choose a point on either side of the line. We cannot choose a point that is on the line. So if my red line here is the graph, then I cannot choose a point on this line. So I have to be careful not to choose a point on the line. If I can, though, I will choose the point 0, 0 to test. Okay, and why are we doing that? It's because no matter what the equation looks like, the origin, which is here, that would be 0, 0, makes the x and y values that are easy to work with because we're using 0. Now you could use 1, 1, again, as long as it's not on your graphed line. But we're testing that point because, see, the line tells us where we change from truthfulness to falsefulness. So maybe the left side is true, maybe it's false. Maybe the right side is true or false, but it can't be both sides of the line. So we test this point, which I would say is on the right side of the line. If I end up with something true, this goes to this fourth step here. If I test this point and it ends up being true, then I shade that side of the line. So if it's on the right side, I shade the right. If my red line, so let's go back here. Let's say my red line were somewhere like right here. Okay, now that green point is on the left side of the line, and if it were true, I would shade this side of the line. Now, again, it can only be true or false. So if this is false on the left side, then I would have to shade the other side. That's what this is telling us here. Now, as fun as that sounds, it's probably clear as mud right now. So we got to look at an example. So let's take a look at our first example. So again, we're looking at this like an input-output machine. I will choose values to put into the machine, and then we will see what comes out of the machine. So right now, this is our inequality. Y is less than negative 2x plus 4. Now, the less than tells us we'll have a dashed line, but I'm not worried about that right now. We're going to graph this like it as an equation. So again, I'm not worried about the less than. I only look at equal to because this is going to give me the line on the graph. Now again, while I'm using the input-output machine, some of you may see that you've got your y-intercept and the slope, and you can graph it that way. But again, since there were a lot of students that struggle with that, I'm going to skip it. So I will build myself a table of x and y values to correspond with each other. We'll set up 4 points here. That should be enough. And the first value of x, as I usually will, I have chosen an x value that is 0. So I look at my equation, y equals negative 2x plus 4. But now I replace the x with the x value I chose, which is 0. Now that's y equals negative 2 times 0 plus 4. I really don't expect you to do that by hand or in your head. Put it in the calculator and see what happens, but this will tell us the corresponding y values for. So this is an ordered pair of 0, 4, which now I can put on the graph here. Okay, so that's my ordered pair, 0, negative 4. That's my first ordered pair that I can put on the graph. Now that I have that, I will choose an x value. Since I just have I don't have a fraction like we did in the bell work. It's just negative 2. I can choose any value of x, and that will work. So I'm going to go with nice values like 1. Okay, so again, rewriting the equation, y equals negative 2x plus 4. But again, I will replace the x with the x value that I have chosen, which is 1. Now, you may have chosen a different value, and that's okay, but your graph is going to end up looking the same. So we put this in the calculator, and then I get a value of positive 2. So that's an ordered pair of 1, 2, which again, I will now put on the graph. 1, 2, here. 1, 2. Now that would be enough to put a line on your homework, but since I'm doing this by hand, I'm going to continue, and I will choose an x value that is 2. You notice I'm not even choosing negative values because I don't have to right here. Especially once I get 3 points, it'll create a definite pattern, and then I will even do a 4th point today. So our equation, y equals negative 2x plus 4. Now I have chosen an x value that is positive 2. So I replace that into my equation. When I put this in the calculator, I get a corresponding y value that's 0. So now I have an ordered pair of 2, 0. That's on my x-axis here at 2, 0. So the pattern is confirmed right now on my graph. Right? These 3 points make a definite pattern. 2 points makes a pattern, but it's not definite until you get a third one. So like I said, just because I'm a math nerd, I'm going to go the extra mile and say, you know what? I'm going to try an x value that's 3. See, I'm just going up by 1 in my x values. So I am putting 3 into this machine, and the machine is functioning this way. It's saying y, or the value that comes out, is negative 2 times your x plus 4. Okay, so what has just been put into the machine? I just put into the machine a value of 3. So it says, okay, let me calculate. Negative 2 times 3 plus 4 would be negative 2. Okay, so I got 3, negative 2 on my graph. 3, negative 2, which would be right here. And again, it's still within that pattern. Now, could we put more points on the graph? Yes, we could, but that's already pretty tedious as it is. So I'm gonna stop there, and let's see if we can put this on the graph in a decent way. Okay, I'd say it's not my greatest work, but it'll do. I'll put arrows at the end, and then that's pretty good right there. All right, so this is the line that goes on the graph. The problem is, now that I've got my line on the graph, right, because we've got our points, really what happens now is we've got to figure out if this line is going to be dashed or solid. Well, since we were just dealing with a less than symbol, it's not equal to, so our line on the graph should be dashed. Dashed or dotted. You get to choose which one. So I'm going with dashed because that's the options that my computer gives me. Okay, so again, we were looking at this kind of scenario with less than or greater than. So we're looking at it dotted. I used the dashed line, and that's okay. Here are the points. They're no longer labeled, and Again, we're just going through the steps, right? We solve the equation, we put in inputs and outputs, we put the line on the graph, and then we realized it should be dotted, so we dot this up or dash it up. Next, we're going to choose a point on either side of the line. We'll use the origin 0, 0 if it's possible. So I put that point here in purple. It is my test point, and then I'm just checking for truthfulness or falsefulness. So let's go back to the inequality. So I have to use the inequality now. But from the origin, the x value is 0, and the y value also is 0. So the inequality is looking like this. 0 is less than -2 times 0 plus 4. And I will put in question mark above that symbol because I don't know if that is true. But I do know that once I put this into my calculator, -2 times 0 plus 4, I get a value that's 4. So I have a value that, or an inequality that shows 0 is less than 4. That is how this inequality reads. 0 is less than 4. Well, even saying that out loud, or even whether we don't say it out loud, we see that this is a true statement, okay? So our test point proves true in the inequality, which means that all the points on this side of the line, because see this origin is on the left side of this line, all the points on the left side of the line are true. So I will now shade it, and I'll use the same color purple. So get something, we're not looking for perfection here, so something like this. Okay, now the shaded area shows us, once again, all the values that are true. So, as we've done this, we've shaded, and all these ordered pairs show true, which means that you could have, if you wanted to, you could have chosen, for example, this point right here at -8, 5, and you could have tested that in this inequality, and you would have had a true statement still. You could have tested any point. You could have tested this one down here at -8. It would have made the inequality true, okay? So we've chosen the point on either side of the line. We found that by testing this ordered pair in the inequality, it was true. So since it was true, we shaded that same side of the line that this point was on. Now again, let's say that this was false here, then I would have shaded the other side of the line, because it can't be true on both sides of the line. It can only be true on one side. So this is how this works. Again, we went through it step by step. Now we have to do it, we have to try it on our own. So you may have to pause the video, but take a minute, try this one out, and then we'll go over it. All right, if you need more time, again, you can pause the video, but here, I'm going to start by just finding ordered pairs that go on this graph. So let's set this up. Shouldn't need more than just a few. So 4 points will do it. And again, I always like to start with an x value that's 0. I don't care if I've got a fraction here. X being 0 is going to be very nice. And then I rewrite the equation. Again, I write it as an equation, though, not as an inequality. So y equals -3/4 x minus 2. But I've chosen an x value that's 0, so I'm putting that into the machine. So I replace the x with 0, okay? So again, it's my input-output machine, my function machine. I'm putting in 0. I want to see what comes out. So in my calculator, I type in -3/4 times 0 minus 2, and I get -2. You should have gotten the same value, the same ordered pair. So I put 0, -2 on the graph there. 0, -2, found it. And I'll label it 0, -2. Okay, that's my first ordered pair. Now I see my denominator is 4, so my next x value should be a multiple of 4, which itself would be its own multiple, 4. Now this is to prevent any fractions or decimals coming out, because we don't want to graph those, or have to. So I'm going to say y equals -3/4 x minus 2, but again, I'm replacing the x with the value I've chosen, which is 4. And again, 4 will help us to avoid any fractions or decimals. So y equals, let's see, this is going to be, put this in the calculator, get -5. Okay, so I have the ordered pair 4, -5, which I can put into the graph, 4, -5, right here. Boom. Okay, now 2 points is nice, but I should be able to fit another point on there. I'm going to choose an x value that's 8 because if I put 8 into the machine, I see that the denominator 4, 8 is a multiple of 4, and then what comes out should be a whole value. So the equation looks something like this. Y equals negative 3/4 x minus 2. But I've just chosen to replace the x with 8. So I'm in the machine, I'm putting in 8, and what comes out looks like this is going to be negative 8 right there. So my ordered pair ends up being 8, negative 8, which I can put on the graph, 8, negative 8, which is here. Okay, so that puts some points on the graph. We could graph another one. Now, the thing about going further here is that if you want to stay positive, the next multiple of 4 is 12, and that's off the graph for our x value. So we got to go backwards, and that'd take us to negative 4 instead. So if we make that x value negative 4, then we go back to the equation. Y equals negative 3/4 x minus 2, and we replace the x with negative 4. So here's what that does. It takes the y value and makes it for us. Let's see, negative 3 minus 2 is 1. Looks like, so negative 4, 1. So that would put us at negative 4, 1 right here. And again, that is still within the pattern, negative 4, 1. Okay, so I'm now ready to take those points and let's draw a line. Now again, before we put the line on the graph, because we did make that an ordered pair, by the way. But before we put this on the graph, what kind of line are we going to need? Is it going to be solid or is it going to be dashed? Well, this line, since we have the equal part of the inequality, this is going to be a solid line. Okay, so I can go here, I can use some technology, and let's see if we can make this fairly decent. There's a decent solid line, and I'm using technology, so that makes it fairly easy as well. But there we go. It's going through all 4 points that I put on the graph, and it looks good. So this is the graph that represents this inequality, but it would have been as an equation, right? Okay, so we put the line on the graph. It's a solid line. The last thing we got to do is check and test a value on the graph to make sure, to see which side of the line to shade. Okay, so I'm going to test. We've got to choose a point first, and I'm going to choose the point 0, 0. And this will be my test value, okay? So, in performing the test, so that's what I'm going to do. I'm going to test this. But I've got to use my equation, or sorry, the inequality rather. So I've got y is greater than or equal to negative 3/4 x minus 2, and we're testing the ordered pair 0, 0. So we start out saying the x value is 0. And then also the y value is 0. And then we plug this into the rest of the equation, okay? Now, just to go back, we can use the ordered pair 0, 0 because the ordered pair 0, 0 is not on this blue line. If it were a point on that line, I would not be able to use it. So we've got our x and y value put in there, the ones that we chose to test. And then I'm going to check this for truthfulness. So there's my question mark over the inequality. So what do I got? I got 0, and it would read 0 is greater than or equal to negative 3/4 times 0 minus 2. That would be a total, if you were to put that in the calculator, you should get negative 2. Now 0 is greater than or equal to negative 2. That reads true. Now again, 0 is not actually equal to negative 2, but it is bigger. So if we look at the inequality, it's eating the bigger value, which makes this true. So since the test point was true, and the true point that I've tested is on this side of the line, then I need to shade this area of the graph. So I pull out a kind of like a highlighter here, and that's pretty good, okay? So that's what it's supposed to look like. And again, the shaded area tells us that if you were to test any ordered pair in the shaded area, it would make this original inequality true. It also means that if you were to test any point in this non-shaded area, such as let's say -8, -3 here, if you were to test those two ordered pairs, or this ordered pair, in this inequality, you would end up with something false. Okay, which again would also indicate that um, what you put in would make the inequality false. So it's kind of like the function machine wouldn't be working, but that's it. That's all we got to do on this one. We got our solid line, we got our shaded area. That's it. Okay, so this is kind of a new one. We haven't really seen an inequality like this. This is kind of in what we call standard form. So like we saw last time as well, this is kind of, it's not very clear about input and output based on this setup. Okay, now we can still put stuff in, and then we can see what has to come out from there. And that's actually what we're going to do. But again, the first thing I want to do is treat this inequality as though it were an equality. So I don't really care about the less than or equal to part. I'm going to treat it as an equal sign so I can solve it like an equation. That will tell me where to put the line on the graph. Okay, so I got my x and y. Should be able to fit a few in here. Okay, so the first thing I'm going to do is I'm going to say x is 0 because it's very easy to work with. Now in doing this, just like we saw last time, at least when you're doing inputs and outputs, you may end up with some values that don't work very well, meaning that you may put something in that looks good, but something comes out that looks bad, meaning it has a decimal or a fraction. We don't want decimals or fractions. We can keep them on here to kind of give some estimates, but we want whole values to work with. So I will start with x is 0. Okay, so I'm going to go to the equation, which we already have. It is 3y plus 6x equals 12, and I have chosen a value of x is 0, so I replace the x with 0 in the equation. I solve it. Now again, the nice thing about putting 0 there is it makes that part of the expression 0, which leaves me with the equation of 3y equals 12. And then I just got to divide both sides by 3 to make this y equals 4. So this one works out for us. It gives us the ordered pair 0, 4. That's y-intercept right here. Now the next value I can choose, I could say, well, what happens if x, let's say that x is 1. Okay, so for the equation, 3y plus 6x equals 12, I'm saying this function, I'm going to put in 1 for my x, so I replace the x with 1, and then let's see what happens here. So 6 times 1 is going to make 6, so I'd have 3y plus 6 equals 12. Now principles of equality, I'd have to subtract 6 from both sides, making 3y equals 6, and then divide both sides by 3, tells us that y is 2. So this one works out again. I didn't end up with a fractional value, and so I can say, well, x is 1, and the corresponding y value is 2. So 1, 2 would be located here on the graph. 1, 2. Now, you could make a stair step there and say, well, that's good enough to start making stair steps, but I've already started this process, so I'm going to proceed with an x value in my table that is 2. So what does this do to the equation? Well, 3y plus 6x equals 12. It's getting a little sloppy in there because of the work, but I'm going to replace the x with 2 and then solve from there. So 6 times 2 is 12. This would equal 12. 3y plus 12 equals 12. Solving for y, I'd subtract 12 from both sides. So 3y equals 0. Dividing both sides by 3. And we get a y value that's 0. So I now have the ordered pair 2, 0, which I can put on the graph. That's my x-intercept here at 2, 0. And again, you could put more points on the graph if you'd like, but this should do it for us. And so now I'm going to put my line on the graph. Well, before I do, what kind of line do I need? Well, up here, it was saying that it could be less than or equal to, and since we have that equal part in the inequality, we're going to make it a solid line. So I just got to connect these points. Let's see if I can do that in a decent way. That's fairly decent. So I'll put some arrows here. There and there. And that is the line. Okay. Now, if it was dashed, then it would have been just a less than symbol. It wouldn't have the equal part in it. But it does have the equal part, so I have to make this a solid line. This is communicating to people looking at this that The solid line means that the original inequality, all these values, all these points, these ordered pairs on the line would make the original inequality true. So that's my line. Now I look again and I see that this line is not going through the origin, which is great news because then it lets me test the origin. So I'm going to test the origin at 0, 0, and you're welcome to test whatever other point you want. You cannot test a point that is on the line. So I'm going to take the equation and rewrite it, and so I can test. So that's what I'm planning to do. I'm planning to test my origin at 0, 0, where the x is 0 and the y is 0, because that makes it very easy to work with. Okay, so there's my inequality, and I know that my x value is 0, but also the y value is 0. So what I have is 3 times 0 plus 6 times 0 should be less than or equal to 12. Now we're testing this though, so I'm going to put a question mark over my inequality and see what happens. 3 times 0 is 0, and we also have 6 times 0, which is 0. So yeah, that makes that very easy to calculate. So 0 plus 0 needs to be less than or equal to 12. Well, 0 plus 0 is 0, which last time I checked is actually less than or equal to 12. That would give us a true statement. So, since the testing value that we have there is true, that means we need to shade this side of the line. Now again, if it's false, I'd have to shade the other side of this line. But this one ended up being true. So let's go ahead and get with the shading. And again, I don't really need to be perfect on this one because I'm doing it by hand. So this little part right here, even though it's garbage, it still works. Okay, that's it. We have the line that we need and we have the shaded area done. So again, just to emphasize this, if you were to test any other ordered pair in this shaded area, it would make the original inequality true. If you were to shade any of these ordered pairs in the non-shaded area, it would make the original inequality false. Okay, take a minute, try this one. You may have to pause the video, and then we'll go over it. I hope you guys had enough time to try that one out. Let's get started here. Again, if you need more time, just pause the video. So I'm going to treat this like an equation. X minus y equals 3. So a little bit less calculating than that last problem, but I'm going to make myself a table, which will then give me some ordered pairs. Now, I'm only doing 3 points because there's a little bit more work with this type of structured equation, the standard form equation. And as usual, I will start with an x value that is 0, and then we'll see what happens there. Hopefully it works out nice, but the equation is x minus y equals 3, and we have chosen to replace the x with 0, at least I have. Okay, so 0 minus y equals 3. I can treat that as just negative 1y equals 3, so just divide both sides by negative 1, and we get a y value that is negative 3. Okay, so I have an ordered pair of 0, negative 3, which then I can put on the graph. So from the origin, just down 3, boom, that's my y-intercept at 0, negative 3. Okay, so we got that on the graph. Let's try another value. I'll try an x value again, that's 1. Let's see how that works out. So we have x minus y needs to equal 3, but now we've replaced the x, or we've chosen a value of x that is 1. So I'm putting that into my function machine, and I will solve. So I'd have to get rid of that 1, so minus 1 from both sides. Now it's negative y equals 2. Divide both sides by negative 1 to make that y equals negative 2. So we have now an ordered pair of 1. Let's see if I can do a better negative 2 than that, though. A little bit better. So 1, negative 2, that's my next ordered pair. Boom, right there. Okay, so we see that pattern, and again, that should be good enough to make a line, but I like a third point just to kind of confirm the pattern. So I'm going to choose next an x value that is 2, and we'll see how that goes. So it's x minus y equals 3. We just chose an x value that is 2. So solving this one, I'd have to subtract 2 now from both sides. 0 that out. Now I've got negative 1y equals 1. Divide both sides by negative 1. So this works out for us. The corresponding y value is negative 1. This gives me an ordered pair to put on the graph. 2, -1. And again, you can kind of see that stair-step pattern coming to fruition, hopefully a little bit because the points are a little closer together. But that's enough for me to make this line. Now again, what kind of line am I going to need? Well, this inequality does not have an equal sign, okay? So it's just a greater than symbol. Since it does not have an equal part of it, I'm going to make it a dashed line. You could say dotted as well. It doesn't really matter. It's just I can't show a solid line. So the dashed line is going to indicate that all the values on the line would make the original inequality false, because that is where the values would be equal to 3. So let's see what kind of line this gives us. Okay, that's what I got right there. It's not my best effort or my best work ever, but I'm going to keep it, okay? Now that we have our dashed line on there, let's go ahead and test a point. I'm going to test the ordered pair 0, 0 again, because it is a very easy value to work with. So up here in the top right, that's where I'm going to start working, showing that I am testing the ordered pair 0, 0, which makes the x value 0 and the y value as well 0. But it's just testing. It's not on the line. It's not supposed to be on the line. We're just testing to make sure that it will give us a true statement. So the inequality rather, because we do need to test the inequality, x minus y should be greater than 3. So in testing this, we already know we have an x value that's 0 and a y value that is 0. So it now shows 0 minus 0 should be greater than 3. Now I don't know if that's true, so I'm going to put a question mark over my inequality there. Well, as it turns out, I got 0 minus 0, which is just 0, and it's now showing that 0 is greater than 3. So that's even how that reads right there. I'm saying right here that 0 is greater than 3. But 0 is not greater than 3. So that tells us that we're looking at a false statement. So our test point ended up being false. So that means all these ordered pairs on the same side of the line here are false as well, which means we need to go in here and shade the other side of the line. Let's see if I can do this half decent. That's decent. Okay, so again, this completes it. Again, showing that if you were to test any other ordered pairs in this non-shaded region, you'd end up with something false with this inequality. All these ordered pairs in the shaded region would be true. And since it can't be true on both sides, then we say that once we know that this side is false, the other side has to be true. And that's it. Okay, there's our objectives for the day. I can graph linear inequalities with function input and output, and also I know where to shade on the graph. So hopefully you guys feel comfortable with this. Get started on the assignment, finish, so that you don't have to take stuff home and you can spend time with your families instead.